Okay, off we go. Page 531, problem 25. That would be in homework 38. The sister problem here is 28. So here we are solving triangles. The previous video, I believe, was solving right triangles. And at that time, I made the comment that, when you're solving right triangles, you're kind of way ahead of the game in the sense that you know one of the angles, right triangle is 90 degrees, and you know that that triangle obeys the Pythagorean theorem. So not so with other triangles. Excuse me. And you're going to find that we're going to go through a set of problems here, some using the law of sines, some using the law of the cosines, some using one or the other. So given that you don't really know anything about these just run-of-the-mill obtuse or acute triangles, you don't know anything a priori. It turns out you need to have three pieces of information in order to solve the whole triangle. You need two angles and a side, two sides and an angle, three sides. Three angles won't do it. Three angles. There are all sorts of different triangles. They're all similar that satisfy the input of three angles. So that's what you got to deal with. And the problem that we're dealing with right now is called an SSA, or side-side angle. Different from a side angle side, right? Or different than different than a side angle side, where the angle is between the two sides that you're given. Let's look at this problem in particular. So here's a triangle, ABC, all caps for the angles, lowercase a, b, c, the sides opposite those so-named angles. This problem gives you this base angle A is 50 degrees. This side A equals 3, this side B equals 3. So let's think about that for a second. Okay, so you don't have a side down here big, you've got an angle against it, yeah? And you've got two sides. We'll call this one A, we'll call this one B. Let's think about this a little bit, all right? Let's look at this situation, because this is the situation that comes up anytime you are given information in this side angle format. So I've just drawn one particular case. I'm going to drop here the height from whatever triangle that would ensue. And I want to look at and comment on a couple of particular cases, because you actually have to address this at the outset. If I go up to the top, this kind of ominous direction for problem 25 says solve all resulting triangles, and maybe you went, your reaction was, huh? What do you mean resulting triangles? Here's what they mean. If A, this side that's given, is less than this height, if that's the case, look, this A just dangles here. It never makes a triangle that can meet this line off of which angle A is met. I don't know how long this line is, side A, but, or side, I guess it's, if B is down here, side B is here, so angle B is someplace down here. This is angle C. So this side C, not given, but it lies along this dotted line someplace. It lies where side A and angle C fit to make an intersection. But if A is less than H, look, it can't reach. A cannot reach. All it can do is just sort of swing on this arc. So there's no triangle. If A is less than H, then no triangles. And if you can establish A is less than A, you can't find any triangles, you can move on, say, I'm done with this problem. But if A is not less than A, perhaps A is equal to H. Yeah? A is exactly this length. This height is equal to this side, and sure enough, there's one triangle, one, and in fact, it's then one right triangle ensues. What happens if A is greater than H? A is, I'm going to do it, I'm going to say it. A is greater than H. What happens then? Well, if A is greater than H, so it's maybe this long, then look, if it's this long, then you can make one triangle, but you know what? You can make a second triangle. Here's one with angle A, side B, and side A. Here's another one, same angle A, same side B, same side A. Two triangles. And two triangles ensue. That's what we mean in that situation. If that's the case, you've got two to find. And then the last situation is if, what do we want to say? If A is greater than B, okay, then you're back to just one triangle. Right? If A is longer than B, okay, it's this long, then you can only make one triangle. You can't find another one interior here, right? So this condition actually is if A is, how do I write this? If A is greater than H. How do I write? A is greater than H but less than B. Then there's two triangles. If A is greater than B, then there's one triangle. Okay, there's the four conditions, and you've got to check that. So, geez, I've got 3 minutes or 4 minutes or 5 minutes invested in this. We haven't done anything. Let's take a look at this problem. Okay, this thing says this is equal to 2. This is equal to 3. A is equal to 50 degrees. I've got a height. Okay, and what is that height? I don't know. That height is such that the sine of 50 is equal to H divided by B. I'm going to put it in like that, right? Here's a little right triangle. H equals 2, 50 degrees. The sine, the opposite over the hypotenuse, is H over 2, is the sine of 50 is H over 2, which says that H is equal to 2 sine 50 degrees, which is equal to, get my calculator, here comes a 50 degrees coming at you, there's a sine, and I'm going to multiply by 2, and I'm going to get that H is equal to 1.53. So H is 1.53. H is not bigger than A. Okay, A is 3. H is not equal to A. In fact, A is bigger than H. Yeah. And A is less than B. I'm sorry, but A is not less than B. A is also bigger than B. Okay, well, I guess we could have gone right there. A is 3, B is 2. All right, so there's only one triangle. Only one triangle? Great. Let me erase that. And let's go find the triangle. I seem to be a little loquacious this time. I'm not doing this as fast as I would like. So how are we going to solve this particular triangle? We're going to solve it like this. We're going to use the law of sines that says that the sine of angle A over A is equal to the sine of angle B all over B is equal to the sine of angle C all over C. The sine divided by the length of the opposite side, that ratio is the same for all the angles. So in other words, this ratio, sine 50 all over 3, which is sine A over A, is equal to the sine of B all over 2, okay? Which says that I can find B as the arc sine of the quantity 2/3 sine 50, okay? So let me calculate 2/3 sine 50. There's the sine. Here's 2 times 3 divide. That is the arc sine of 0.51 dot 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 b, and I'm going to just take the arc sine of that quantity, and I'm going to find that that is equal to 30.7 degrees. Okay, so I've got running total. A is 50, B is 30.71. We're going to find C right now, angle C, because this plus this subtracted from 180 gives you angle C. So there's this plus this, change the sign, 180, oopsie, 180, I can't do this. How do I get rid of that? Yikes. About 180, 180, 80.71 subtract. Could have done that in my head faster. 99.29. So I've got all the angles now. I've got A is equal to 3. I've got B is equal to 2. What the heck is C? I will get it from sine C all over C is equal to this sine 50 all over 3. So that's going to turn into sine of C is the sine of 99.29 divided by the sine of 50. C goes here, 3 goes there, that's equal to C. If I can do this, we can call it good. There's a sine, 50, there's a sine. Divide those two, multiply by 3, and I get C is equal to 3.86. Okay. So, sorry, that might be the longest video we've made, but I took the occasion to do a little instruction on the technique rather than just doing the problem.